Hey everybody, how you doing? Bill Grismore here with 27 Virtual. Thanks for joining me in this video presentation. In this video, we're going to take a look at the difference between the VM kernel ports in 5.1 to 5.5. Now in the previous video, we just kind of learned what a VM kernel NIC is, what a VM kernel port is. In this video, we want to compare what happened between versions 5.1 and 5.5. So let's take a look. All right, let's take a look at it. So in this graphic, you can see that we have two ESXi hosts. And on the left-hand side, we have a host here that is ESXi 5.1. On the right-hand side, we have an ESXi host that is 5.5. And what we want to do is compare the differences between how our VM kernel NICs work in 5.1 versus 5.5. It's actually pretty straightforward. If you go back to 5.1, what you're going to see is that you have only a single TCP/IP stack. So if I have only a single TCP/IP stack in my environment, what that's going to mean is that we only have one routing table and one DNS entry capability. So if I'm sharing a routing table with all these different VM kernel NICs, that means I can only have one gateway. So typically what we do is put each one of our VM kernel NICs on a different VLAN. So different VLAN means different network segment. So if I'm putting the management on 10 and I plug this first one here into VLAN 100 to kind of match these guys up. And then I take the vMotion VM kernel NIC and I'm going to plug it into this port in this port group right here for vMotion. That's on VLAN 200. And I'm going to do the same thing here for IP storage, and I'm going to plug it into this port here, 300. So typically what we want to do is with our VM kernel NICs, we want to place this different type of VMware management type traffic that's specific to the ESXi host-to-host communication traffic. We typically want to, at the very least, put it on a different VLAN tag. Now we could, even if we have enough uplinks, potentially put this traffic onto different switches. And we talked about that in the last video. But really the main thing here is in 5.1 and older, I only have one TCP/IP stack, which means I have one gateway. So the question would be, out of these VM kernel NICs that we have configured here, what would make the most sense? Which one of these would I leverage my gateway for? And the answer would be management, right? So this would be ding, 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 here's the winner, right? So that means management would actually get the gateway. So that means that if I decide to connect to my ESXi host from a different network segment, it knows how to return the traffic back to whatever its gateway would be. So let's say its gateway would be 192.168.10.254, whatever its gateway would be. So that would be the gateway that we would leverage here for management. Now, we could route vMotion traffic, we could route IP storage traffic, but it would require that we actually place a static route on these guys. And that means I have to go host to host, and on every single host, I'd have to put a static route to get across a layer 3 boundary. So if you imagine, if you will, say a couple of racks, and if we had some type of layer 3 boundary between these racks, and I want to be able to leverage somehow getting across this layer 3 boundary, and let's just say we have 3 hosts in each rack. What that means is I'd have to put a static route for vMotion going this way across this layer 3 to this guy. I'd have to create a static route on this guy to be able to get back the other direction and return this traffic going the other way. I'd have to create a static route to go back the other way. A lot of work, isn't it? So this is kind of a back and forth I'd have to do to get this working. So I'd have to build static routes back and forth across these racks. Now, maybe I could come up with some way to automate it. If I have Enterprise Plus, maybe I could build it into a template per rack or something, different templates per rack. There might be a way to simplify it, but that's a lot of work. So with a single TCP/IP stack, since I'm sharing my routing and my DNS information, and since I typically cut up my management, vMotion, IP storage into different networks, different VLANs, the only way to really get across layer 3 boundaries with vMotion or IP storage, it would be to leverage static routes. And then the next question would be, does VMware even support that? You know, at what version of ESX could I even be supported to put a static route on a vMotion stack, right? I know for sure we could do it in 5.5, but I don't even know about 5.1. I'd have to go back and take a look at that. So it's very, very limiting. But a lot of the stuff that we did in the older versions, we really didn't need to have a gateway, or we didn't really need to route vMotion or IP storage. There could be some situations where maybe we would do some routing with maybe NFS or something across different network segments in certain situations, but it wasn't something that we typically did. So I don't want to make too big deal about it, because in 5.1, we weren't really too concerned about needing to have a gateway for vMotion or IP storage, or worried about putting static routes on vMotion or IP storage. It's just something that is indeed limiting. Now, we did have something that we could do before NSX, which was called vCNS. So vCNS is kind of the precursor to NSX. First, there was a little history lesson, I guess would be good here. First, there was vShield. And after vShield, we had kind of rebranded this to be vCNS, vCloud Network and Security. And what we could do with vCNS is we could actually implement VXLAN. So if I put another VM kernel NIC on this host for VXLAN, let me just grab this guy over here. I'm going to grab this VM kernel NIC. Let's say I had another VM kernel NIC I could stick on this host. And let's say this VM kernel NIC was for VXLAN. I could definitely give it an IP address. We'll do the 40.101/24. Without a doubt, we could create a VM kernel NIC for VXLAN, and we could put an IP address on it, but we couldn't give it a gateway. So I'd have to do a static route to move traffic across a layer 3. And the only thing that we supported in VXLAN for vCNS to move our what's called BUM traffic, broadcast, unknown unicast, and multicast traffic originating from a VM. The only way we could move this traffic would be to actually leverage multicast. That'd be the only way we could move that traffic. So if I had a layer 3 boundary, as I have depicted below, if there was a layer 3 boundary between my racks, and I want to be able to leverage multicast, I'd have to implement something called PIM, or Protocol Independent Multicast. This is a protocol within the multicast family that would actually require you to route multicast traffic. So on my physical network, my switches would have to support IGMP snooping and an IGMP querier, and then something called PIM. And that way I could actually route my broadcast, my unknown unicast, and multicast traffic originating from my VMs. So yeah, we could do it, but that was the only method that we had. Let me emphasize that. This was the only method that would require multicast on your physical network. And that was kind of hurting the deployment of this kind of VXLAN on vCNS, because this was my only method to replicate this BUM traffic with vCNS. It made it hard for a lot of customers to deploy vCNS, because not a lot of customers out there necessarily wanted to add multicast support on their network. Now, if they were in the financial services industry or some other type of industry where they're already doing multicast on their network, you know, maybe it would work for them. But just generally speaking, across the board, multicast is not something that you would go to deploy just to support VXLAN with vCNS. It's just like, I'm not going to do that. So you would never end up adopting VXLAN as the technology for vCNS. Okay. All right, so excuse me. All right, so now how do things change? So if we go to 5.5, how is it going to be different? Well, it's going to be a lot different because in 5.5, when you deploy your VM kernel NIC for VXLAN, now we're going to get a dedicated TCP/IP stack. So if we kind of take this guy that we built over here, I'll just grab this guy like this. If I get the right tool here, let me just grab him. And we're going to plug this guy into our VM kernel over here. And we're going to assign him an IP address. So we'll give him that same 192.168.40.101/24. And we're going to assign that IP address here. The difference is that now we have a TCP/IP stack that can be used for all three of these guys. And it still just has one routing table. So I still have a gateway that I could use here for management, my 192.168.10.254, as we showed on the left over there. So it'd be the same type of thing. I'd still have one TCP/IP stack for all three of these guys. And again, management would be the only one that would get a gateway, because typically, again, vMotion IP storage don't really need it in 99.99% of the cases. But over here on my VXLAN, I would now have an additional TCP/IP stack, which means I get my own routing table and my own DNS capability. So I get a brand new stack here. That means that this guy can now have a gateway. This means that when I implement VXLAN, now with the kind of the newer version, if you will, of vCNS, so we kind of move forward in time, and VMware is now taking, they purchased the company Nicira. They had an existing product in vShield and vCNS. They got all the capabilities of the OVSDB capabilities that came with the product from Nicira. And they took some of the pieces of what they had with vShield and vCNS, and then some of the things they learned by adding on the Nicira acquisition, and they kind of mixed that all together, and they put it into something called NSX for vSphere. So with NSX for vSphere, or NSX-V, we call it, I now get the capability to have VXLAN, which I had in vCNS, but one of the things that's important about this is I have to have a 5.5 host or higher, because I need to have this additional dedicated TCP/IP stack. Because when we get into this situation down here again, let me copy and paste this over. When I get into this situation again right here, where I have the two racks, and I want to be able to move back and forth, what I don't want to worry about doing is creating a static route for VXLAN. I want to be able to take traffic with VXLAN and extend a layer 2 boundary across these racks. Let me just use a different color down here. I want to take a layer 2 switch, an NSX-based layer 2 logical switch. I want to be able to extend it across this rack, and I want that layer 2 to extend all the way across, right? So this layer 2 would extend all the way across all these racks, even though there's a layer 3 boundary. And I want the VXLAN to work, and I don't want to have to worry about putting a static route in. Actually, you know what? Let me get rid of this for a minute. And let me just put another rack pair here, because I want to make this very clear. So what I would have is, again, my two racks. We'll put the 3 servers in each rack. And we're going to grab this. And we'll copy it. And I have my 2 racks. And basically what I want to do is take a layer 2, and let me put a layer 3 boundary in the middle here. We're going to put a layer 3 boundary in the middle. So there is definitely a layer 3 boundary here that separates these 2 racks. And I'm going to create a layer 2 extension using VXLAN. So I'm going to create a layer 2 extension, And this layer 2 is going to stretch all the way across these racks, across this layer 3 boundary. And I've got a layer 2 network that stretches all the way from one side to the other. This is all one network segment. So what that means is that I have something like, I don't know, 172.16.10.0/24. So this is a network segment. And basically what I'm saying here, let me grab this. I want VMs to plug in on both sides of this layer 3, and I want them to be on 172.16.10.0 no matter which side of the layer 3 they're sitting on. So if you can imagine a VM plugged in over here and a VM plugged in over here, and each one of these VMs is plugged into the same layer 2 network on each side of a layer 3. So this VM number 1 right here can actually have an IP address of 172.16.10.11/24. There's a layer 3 boundary there, and this VM over here can actually have a 172.16.10.12.24. They're on the same layer 2 network, but they're on the other sides of a layer 3 boundary. That's what VXLAN does. It's pretty basic, really. Nothing really too complicated about it, but that's what we're achieving. Now, the reason having a 5.5 host is so important, in order for me to move traffic from this network card, this VNIC and this VM, to have it go out to this port right here and to traverse across this layer 3, there's going to be some type of a physical layer 3 device sitting here, some type of a router, let's say. And that router is going to have an interface in it on this side, and the router is going to have an interface over here on this side. And that's going to be whatever the gateway is that I specify for my VXLAN. So what's going to happen is I need to be able to know what that gateway is going to be. So what I would have on my host is a VTEP. I'll just put a V for VTEP. And this VTEP might have a gateway on this side as, let's say, 40.254, just like I have drawn up there, right? This guy right here, the 40.254. And then over here on this side, this guy over here, this VTEP here might be something like 50.254 would be my gateway. And that would be this gateway right down here. So I have a gateway of 40.254 and a gateway of 50.254. So, imagine another whole host over here that's been deployed that has a VTEP, but on the other side of that boundary. If I don't have this dedicated TCP/IP stack, I would have to put static routes in, right? I'd have to put a static route in here, just like I drew previously. Put a static route here to get the VXLAN traffic to go this way. And then I'd have to go to the other side and put in a static route on this server to be able to go the other way, right, to this layer 3 boundary. And I'd have to do that on every single host, back and forth, back and forth, back and forth on each side of this layer 3 boundary, right? I don't want to worry about putting static routes in back and forth every time I want to do something with VXLAN. All I want to do is leverage a gateway. So as long as my hosts are 5.5 and higher, I don't have to worry about putting a gateway on my VM kernel NIC for I don't have to worry about putting a static route, I don't have to worry about putting a static route on that VM kernel NIC for VXLAN. I can just leverage a gateway. One set of servers on one side would have one gateway on one network segment, and the servers on the other side would have a different gateway going back the other way on a different segment. Now, on both sides, those VM kernel NICs can actually use the same VLAN ID, but they would be sitting in different network segments. Now, if I'm in 5.5, though, the one thing I would still have to do is if I want to vMotion a VM from one side to the other, which I could do, I would still, in 5.5, have to create static routes for my vMotion network because I'm in 5.5 still. So I would not need static routes for my VTEP, but I would still need static routes for vMotion. And what I would have to do with 5.5, I'd have to call my VMware tech support people and I have to say, look, I want to be able to do routing with VXLAN. I'm doing that with NSX, but my host is 5.5, and I want to be able to vMotion across a layer 3 boundary. And what that would require me to do is get what's called a request for product qualification from VMware tech support. It's really not a difficult thing to achieve. So this request for a product, this RPQ, if I could learn to type, it would help. This RPQ is something that I would get from VMware tech support, and this would allow me to add that to my service contract. And that way, whenever I have a problem with NSX, when I call tech support, they can look at that right away. It's a little bit of a flag that says, hey, this guy's on 5.5, he's doing NSX, he's doing VXLAN, and he has told us that their company is actually doing static routing for vMotion. The thing that's really cool about this, though, is you can have 5.5, you can have static routes here for vMotion, get it supported with VMware tech support. The VXLAN already has the gateway that's already built in, which works great. And now you can vMotion VMs from one side of the layer 3 to the other, and you can actually vMotion across the layer 3, even though you're 5.5. But you have to put a static route on each one of those. So without spending too much more time on this, guess what we can do inside ESX 6.0 and higher? Can anybody tell me what the new magical thing is we can do if we go now up one level higher and we go to ESXi, I guess I should have there, 6.0 or higher? Anybody want to guess? Actually, let's just do this. Let's just change this guy to 6.0. We'll make this really simple. I'm just going to change this right here to 6.0. And guess what's going to happen? You got it. I'm going to get a whole bunch of TCP/IP stacks. I'm now going to have a dedicated TCP/IP stack with my own routing table and DNS information for vMotion. That means vMotion now can also have a gateway. So my vMotion is going to have a gateway. So my gateway for vMotion will be 192.168.20.254/24. And I've got myself a gateway there for vMotion because I now have a dedicated TCP/IP stack. So now if I'm in ESXi 6.0 and higher, my VXLAN has a gateway, no more static routes needed, and my vMotion has a gateway, no more static routes needed, and I already had a gateway on management. I've had that since the beginning of time. I can even have a gateway for IP storage, right? There's a provisioning stack, and I can also create a custom TCP/IP stack for third-party vendor integration at the kernel level. Right, so now I'm able to route off of these different VM kernel NICs on the host other than just management. I can do it for management, I can do it for vMotion, and I can do it for VXLAN. So now in this picture on the bottom, I don't have to worry about these static routes between racks or even different physical locations even, because maybe I have ESXi hosts across a layer 3 boundary into a DR site somewhere, and I don't have to worry about building static routes, right? So there you go. You definitely want to make sure when you're implementing NSX that you're at least 5.0 or higher. Preferably, we want to be at ESXi 6.0 so we can leverage that gateway for vMotion as well as VXLAN. All right. I hope that helps. Hope you found it informative. That's a lot of information there. It can be very helpful, very good basic stuff to make sure you have the proper infrastructure in place before you ever even start installing NSX. And it also helps you kind of understand how NSX works and why we can leverage these different features. Thank you very much. I hope you found it informative, and I look forward to seeing you guys in the next video. Thank you.